let's switch over to the main screen. I hope everyone is having a good week so far. It is Wednesday. It's also the end of the month. So what that means is I have 2 weeks essentially, because my conference talk is coming up on the 16th, Friday the 16th at something like 10 a.m. or so. I'll have more details the closer we come. But it is exciting, and it is something where I think I was thinking last night about where we are in this deep learning sort of adventure, and whether or not I'm going to have to do my emergency switch over to my alternate idea. And I don't think we're going to need to. I feel that... Thank you, Twitch, for telling me I can manage this directly from here when I'm already in there managing it. Anyways, what was I saying? I think I'm going to be able to pull this off. The algorithm they're going to use is not too terribly crazy. As we can see, it's pretty simple. All I need to do is prove that the learning part works, and then if that's true, then I build the game, and then build the neural network, and then sort of do the preparations, figure out what, like, do the practices. Good morning, Miguel. All right, where are we? It's the mnist training. So last when we left off, I think what had happened was we were getting an NaN after not a number after 10, the first 10 rows, which means that it's not the weighted delta. It's not the outer product. That's what's erroring for us. And so, Katali, good morning. What I had figured was that let's switch over to you. On Monday after the stream, I sort of had spent some time during lunch thinking about exactly what was going wrong and what I could do to solve it. And I think that I finally fully understand outer product in order to be able to fix this. So let's go into deep learning functions and take a look at what we're doing with outer product. So we're creating a matrix, and it's inputs.length and the deltas.length. So this is going to be how wide it is, and delta is going to be how tall it is. I think what I want to do is create a new test. So maybe in U. All right, so here's our describe outer product. It should return a matrix that was created from vectors of different sizes. Because I think that's what's happening right now is our outer product is assuming that we have a square matrix, and we don't. I should also add that in so that you can all highlight whenever I make a mistake. All right, so what are we gonna have? So const, since I'm also gonna kind of use this as documentation, let's set this for the inputs. So our inputs are going to be like 1, 2, 3, 4, 5. So let's say we have 5 inputs, and we have deltas, which are going to be 6, 7, 8. So this is going to be a 5 by 3 matrix that we expect here then. So what do we expect? Well, I guess this comes down to what exactly is it that we're trying to do here. We need to create a new weight matrix. and or at least to match the weights. So it's basically going to be the updater for this. And the way we're doing it is scaling the deltas by the inputs. Now the inputs are each column down like this. So because we're using images and it's going to be like various pixels per input, it would essentially be, let's see, pixel 1, 2, 3, 4, 5 on the side. And then in here, we're going to have the weight. So weight 1, so this is going to be input 1, 2, 3, 4, 5, weight 1, weight 2, weight 3. And the deltas right now are corresponding to the weights because that's the number of them we have are for each of the weights that we're going down. And so we need to figure out, well, what is weight position 1, 1? Although when we do this, it's going to be 1, 1. It's a little bit weird to sort of think about it in yx, not xy. But this is input 1 and delta 1. So it's going to be a 6 because it's 1 times the 6 here. Well, the second one is going to be the second input, but times the first weight still. So that's going to be 12. And so forth. And for the second one, it's we're moving on to weight 2. So now it's going to be each one of the weights multiplied by the deltas. And of course, the same for the third. That's right? 40, is it 40, what is, 35. 40. Oh wait, I did it wrong. I mixed it up and I did backwards on that one. It's that's the fun thing about having a brain that sometimes mixes things up. It's the other way around. So it's 8. Come on, you don't need to do that. There you go. This is the expected result for doing a non-square matrix now. So if I'm, I guess our outer product is looking for the inputs. So that's going to be the sides like across, and then deltas, which is going to be down. Whether or not we're actually doing that properly, well, we know we're not. We know we're not because it's not working. We're getting not a number after, X number of these. So let's run these tests. Oh, the computer's a little bit slow today. I leave it turned off overnight. So I think what I could do is quit you. Hopefully that should free up some resources. All right, what were we doing? MPX Mocha. Right, take a look at this. So when we don't have a square, maybe, let's not worry about that right now. When we don't have a square, we start getting these not numbers. So our math is definitely wrong for this. So now that we know that it really is not working, let's fix it. I'm kind of thinking of just throwing this entire thing away and we're going to start over again. Because if we think about it, we want this to iterate over the deltas first. So that's going to be going down. Well, that's the same number of items in this array. So we can return deltas.map. And that will give us the delta. So that's just a scalar number now. We still have inputs. Now, for each of the inputs, we want to multiply it by the delta to then create that that array that goes in that first the first light item. So of course, the inputs is an array, and we want to have the same size. So that means we want to map through this. So inputs.map itself, and we'll get current input. And then we want to multiply the delta by the current input for that top left, and then the next time through the map, it'll go to the next input, and we multiply it by this delta, and hopefully that should be exactly what we think it is. Current input times delta. Let's see if this does any better. Almost. We don't have the NPX problem, but now we have number problems. So 4, 8, 12, 5, 6, 5, 8, 10, 15, 12. Looks like, oh wait. Oh man, it's the reading like what we didn't have. So the 4 was correct on the first one. Let's bring up their test. Where's my, here it is. Also, which one is this? Should turn 2 vectors into a matrix. It's this one that's having a problem. We should probably double check that I actually did this correct. So vector 2 is going to be the down. So this is going to be 1 times 4, 2 times 4. Yeah, so this math is wrong. This is going to be 8, and this is going to be 12. Then 2 times each of these. Oh, wait, so I got this wrong. 1 times 5, 1 times 6. Then 2 times 4, that's 8, then 10, then 12. And then 3 times 4 is 12, 15, 18. Let's try this. Okay, so I'm still running into problems here. Should turn 2 vectors into a matrix. This one is working just fine. So it's our math here. So our first item, we're getting 4, that's correct. We got 8. We expected 5 for this one. And we got 12, and we expected 6. Okay, so that's the problem, is our algorithm didn't do exactly what we wanted to do. Or we didn't really think about what we want to do. So the vector 1 is our inputs. Vector 2 is our deltas. So deltas is going down, down, and these are going across. So 1 times 4, 1 times 5, 1 times 6. I mean, that sort of Looks like vector 1 and vector 2 are switched. I see vector 1 and vector 2 here in this order. It does feel like they're switched. I guess I'm trying to see how I'm, like the math that I'm trying to do is, if I redo this. Also, Kuchen, good morning. Vector 1 and vector 2 switch like backwards here, where I want vector. But I guess how did I manage to do that? But I'm trying to keep them correct here. Let's switch the names here. So these are the inputs, and these are the deltas. Oh, thank you. All right, so for this first one, it's the inputs across and it's the deltas down below. So this first one is the first input multiplied by the first delta. So that's 4. And then it's going to be, oh yeah, so I got the math wrong, definitely. So this is 1 times 4, then 2 times 4. So this is 8. Then 3 times 4, this is 12. Then it's going to be 1 times 5, 2 times 5, 2 times 6. Then 3 times 4, 3 times 5, 3 times 6. I mean, so close, we got 2 of them. So it's the first 99. Okay. Well, yeah, so I know we're wrong here. I'm just trying to like remind myself, or 3 times 5 is 15. Didn't I get that? 3 times 5 is 15. I have 15 here. Expected 15, but we were supposed to get 6. In the second vector. So the second vector should be, oh, yeah, all right. It's 2 times 4. Oh my gosh, how did I get this so wrong? All right. 4, 8, 12. Then this one is the second one. So 2 times 4 is 8. No. God, I keep on thinking about this one. It's this one. So 5, 10, 15. Yes. Okay. Yeah, that's right. And then 6, 12, 18. All right, we finally got that. For some reason, trying to do this like not on paper just trips me up so much because I forget. I just like constantly flip this, and I think that's the dyslexia in me that's constantly hitting in and making it really, 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 really hard for me to remember where it is. I need to like actually hold it with my hands to see it. Yeah, definitely easier on paper. Even though this is a small vector, that's like, it can be really tough. And what this means for us is that in the actual mnist, we should now properly have the weighted deltas. It's the same for you. I hope that's a normal thing and we aren't dumb. Oh no, we're not dumb. It's the way I see it is we all have different ways that we work, and we just have to find the best ways that we work and probably like lean towards that. It's just this would be so much easier if I actually found the cable and set up my Wacom tablet, and then I could switch over to like, I don't know, that MS Paint that I found on a browser one time, and do the math there and figure it out. All right, so if I remove that, we get our weighted deltas with our outer product. We then limit those weighted deltas with the alpha. We then get matrix subtract. We update the weights, and then we have this. The current, we console log the predictions that we made along with the current training inputs, like what we're trying to get. So we have, oh, this is fun to read. I like how there's no commas between the arrays here because of the different console logs. So I need to label these. All right. Predictions. Correct output. Current training image, I think that's what it is. I think so. And using the template string for templating, I could. Pretty print, I mean, I could use the JSON pretty printer too. What I'm really interested in is our predictions is 0 to begin with, but that's because we zeroed out all the weights. So that's expected. And this second to the last one is where we're going for. And then our predictions moved after we updated the weights. And the correct output is now here. Am I going through multiple different ones? Oh, I am. Oh, look at that. Okay. I kind of forgot that I'm not doing exactly what I was thinking of doing. Okay, so let training images index. We're going through 3 of these. I kind of want to first start with just 1. Current training image is going to be equal to training images of 0 dot input. And oh, okay, so comment you out. Current training image correct output is now going to be the training images 0 dot output. So I want to make sure that we're moving in the correct direction here. So we're staying with the same correct output, and we're trying to get towards 1, which it looks like it is right now. Let's go 10 times. All right, look at that. Our predictions is getting up to 0.999999. So that is looking fine. Now we can, what I'm thinking, so the idea of what I want to do is train through all of the images with one pass each. And I don't know if I want to, at that point in time, then test to see how accurate I am and then decide if I want to go another pass, or if I want to then test how, yeah, I think maybe that would be good. The book actually showed that every single training time, so like every time through the loop, it would also then go through the testing images, which we have right here, and try those to see what a percentage of correctness is. And I think the book got close to 80% accuracy by basically stopping at exactly the right time. I don't think I'm going to do that. I have more images also than they were training on. The book trained on 1,000. I'm training on 8,000. And I think they had a lot less on their test set too. So I don't know. Do you have any suggestions for this? Do I want to test, basically go through my loop, do one image, update the weights, and then loop through all of the test images, find out how accurate I am, and then we print the accuracy out? Or go through all of the images one pass and then run through the tests, find out how accurate they are, and decide if we want to go through another pass. That's the question here. You think the way it is done is first train the network and then use the test images. So basically we're going to go one full pass through. Well, and that's the key, right? How can I log the accuracy without the test images? I can log the perceived accuracy. Keep it simple, one pass and then test. Generally, you like to build up in complexity. All right, I think let's do that then. Well, training images is less than, what is this going to be? It's going to be the training images dot length. Because test images are used to prevent the network from memorizing the data. Well, yeah, it's a test to make sure that it's working, not like a learning opportunity. So I get that. All right, so now we're gonna go through every single image and do it once and update. So we'll be getting something like, here's a 1, here's a 5, here's a 9, here's a 0. It does repeat numbers. There'll be a 1, but it won't be exactly the same. It'll be in a different handwriting. I probably don't want to console log here because that will be 8,000 console logs. I think there's a little gnat that just suddenly flew right over my my monitor. After I'm done with this, right here, now we can console log out what we have. The problem, predictions are created inside of this for loop, which means because it's a const, it's going to be lost to us. So I need that predictions. Turn this into a let. I could just let the errors do a little bit of error-driven development here, and we'll just console.log training 1 pass complete. And then we're gonna say predictions. Oh, it's really gonna be predictions. I'm thinking I'm thinking now we just go on and handle the errors. Let's just, I want to see how long this takes. Actually, before I do that, time. All right, so that way we have a little bit of accurate time for that. So we can leave that running while we start to figure out how, oh, there we go. Training one pass complete for 8,000 images. 8.5 seconds for me. 0.16 CPU. Okay, it's not bad. That was actually pretty quick for one pass. For some reason, I thought it was going to take a little bit longer. All right, let's. We need to write the function to help us determine how accurate we are. So let's go ahead and write that in here. Is the time program a Node.js thing? No, it is not. Time is actually a it's a Unix shell script thing. So I can do like time ls, and it tells you how long something any command that you run takes. Reading it is a little bit weird because time is not necessarily the same that we sort of think about it. Typical MSE function. When you have one pass, you test the network and then retrain the network if you want more accuracy. Yes. And so how do we test the network? Well, we have this test data. Essentially, we're going to do the exact same thing that we're doing here, except with none of the updating the weights part. So we're going to predict, run a prediction on each input and each weight. And then, so we're still going to we're going to use our neural network here. So we loop through, we take the test inputs, the test images, we throw them in here, we throw the same weights in that we're updating here. And we check the output, which is that array. We find out which number is the highest and compare it to the output test data. If it's the same position in the array, it is a correct answer. We mark that down as correct. So we can write this function here. So function calculate what would this be? Calculate like our accuracy. Calculate accuracy. We are going to hit the neural network with the inputs. So we need inputs, we need weights, and that's kind of it, isn't it? So, oh, you didn't know about that? It doesn't really come up too often that you need it, but if you're trying to like determine if something is, if you can't like stay there and watch it run and you want to see how long it took, time is a good one. There's another one that just only gives real time, and I can't remember what that one is called. All right, so calculate accuracy. We have our weights. We're going to call the neural network, but before that, we need to know our answers. Like we need to count up the correct answers and the total number. So const the total. I know I can get, this is just going to be the count of the inputs, but the total run count is going to be the inputs dot length. We're also going to have our this should probably be just a let total correct. And we're going to start this with 0. Now we run, let's say we just do it once. We're going to take the first input. So we have to loop through the inputs. We get the appropriate weight. So we need to verify also. So if inputs dot length is not equal to weights dot length, that's not correct. It shouldn't be inputs at weight, because inputs are going to be the width and the weights are going to be like down like that. So actually, I don't know if I need to test this. If I run into a problem, I guess I'll test it then. All right, so calculate accuracy. You know, I bet we could just throw this into this function here. Yeah, let's do that. And we'll test it. Describe calculate accuracy. We'll pretend it exists to begin with. So we have const inputs equals our inputs, in this case, is going to be an array of all of our inputs. So what is that in this case? Like 1, 2, 3. So our inputs is gonna be oh, we need our expected results too, don't we? So if these, we have inputs that are 3 inputs each. So 4, 5, and 6. 7, 8, and 9. So let's say we have 3 sets of inputs that are 3 long each. Our weights, this is going to be interesting because if we have multiple in and multiple out, so let's do our outputs. So the inputs is an array of matrices. I don't think it should be an array of matrices. It's just an array of arrays. So this is our first input. This is our second input. This is our third input. So we could almost imagine that this is, these are, oh man, but if I run the actual thing, no, it should be fine because the neural network will make the numbers all weird and interesting, but ours shouldn't matter that much. So the inputs are this. I wonder if we should inject the neural network to make it a little bit easier to test, so I can basically just sort of change how it works. Here's what I'm thinking. We're gonna have a const it's gonna get a const prediction, and we're going to, so it's gonna get the prediction, it's gonna compare that prediction to the outputs. Yeah, we're gonna normalize it. I guess I'm trying to figure out how to test this when that neural network is right there in the same file. And so it was initially going to rely upon that function. I don't think we should. I think we actually should rechange our neural network. So if we have inputs like this, we have the expected predictions. And I think this is what's really gonna matter here. So let's say I have, it's gonna be an array. Oh, this won't really matter. What? Our neural network. Oh man, I'm having trouble thinking about how I want this to work before I've written it. So I may need to actually write this here first. So calculate accuracy. And I think I'm also running into this problem because I'm not writing it down. So we're going to take in the inputs. We're going to take in the expected results, the expected predictions. We're also going to take in the neural network. And that's probably it for right now. So we need to const correct count. We'll start with that with 0. We'll also have the number of iterations that we go through. We know that's going to be the count of inputs. I feel like for readability, it would be helpful to add that in right here too. So this is going to be the run count, total run count. And that's the number of inputs that we're running it on. We need the weights. All right, so we have our correct count, we have our total run count. We now need to run our neural network for each of the inputs, pass that in. So I'm going to start with just a for each. So inputs.forEach. Don't do that to me. So for each, we're going to grab our current input. And well, we have a problem now because we need the appropriate. Oh no, the weights go with are just the same. So this won't change ever. We need to run our neural network, pass in the inputs and the weights, and we're going to get a prediction. So const predictions equals our neural network. We're going to pass it in. How do you know? Is it just grabbing it based upon the name? I'm not calling calculate accuracy yet. That's pretty crazy that VS Code is actually figuring out that that's what the inputs are going to be. Okay, so we passed the inputs and weights. We now have an array that should be the same length as the current expected predictions. So that's our problem. We need to get the same one. So we have the current inputs, and then we're going to have the index here. So we now need to compare the predictions. So we need the highest, like whatever is the highest prediction, and that's the one it is. And we need the index of that one. So this is going to give us something like 0.1, 0.1, 0.99999, 0.1, let's see, 1, 2, 3, 4. We'll just stay with 4 for right now. And expected predictions is going to be like 0, 0, 1, 0 for a correct one. And for incorrect, it would be like 0, 1, 0, 0. So I need to find that the position that this one, that the highest one is 0, 1, 2. I feel that this is going to be another function here. So function highest position in array, highest index. Largest index. Find largest index. I think what you want, it's built-in math. Ooh, is that the case? Let's open up Chromium. MDN array methods. You may be right. I mean, so there is a find index max. Reference global objects math max. Oh, it's not. So it's not an array. It's a math. Oh, interesting. Where's the search? Why do you make this so hard? Okay. So I'm gonna have to not destructure, spread the array. Oh, but this doesn't give me the index of it, does it? This gives me this number. All right, so array 1, so yeah. This gives me that then I find index, yeah. So what if because we're gonna have some fun numbers here. So what if we have like something like that? So if I do this, it'll find the appropriate one, and then I want to take math.max, and I also want to combine that with array.1. So array1 dot find index. Well, find index needs to take a function. Okay, hold on. So you're gonna be, we're gonna take the current number is exactly equal to this 1. All right, that will work. So math.max and find index. Wait, will that work too? So, oh, because like you're suggesting we do this. Got rid of one too many. Yeah, it doesn't like that. Oh, and then instead of spreading this out, I don't know if that would work. Yeah, I think I need to do it the way I had it listed down here, which is find index, provide a callback function. So I think that's what we're going to need to do. Yeah, we have to put the function as an argument. All right, so, all right, let's array.findIndex. So array.findIndex math.max and then spread array1. I don't know. That did not give me what I wanted to get. That gave me this one. I think what I need to do is I need to get, so I need to get the current value. So it's going to hand this one into here, hand this one into here, hand this one into here. And I want to know if the value is the max of this one. So I have to check to see if value is exactly equal to here. And then it will give me the one I want. So that's what I need to do. So I'm gonna abstract this away into find largest index here. So find largest index. We're going to take the, I guess just the array to find the index in. This one we can definitely do test-driven development for. So I'm gonna comment you out. Let's go back into here. I guess this is going to be our array. And we'll just have like 0, 1, 2, 9, 4. So what do we expect out of this one? 0, 1, 2, 3. So we want to assert dot equal, and this is going to be you just pass in the array that it equals the expected output. So if I run this, we should get find largest index is not defined. That is correct. Now expected undefined equal 3. So we've got everything set up. Now we need to run through this. So the first step is we're going to run this find index off of it. So return array find index. Then we're going to have our current value. We're going to take our current value and we want to make sure that it's exactly equal to, and this is where we're going to have the math.max, and we spread the array in. All right, so that's working the way we expect it to work, which means we can now use this here. So we have our inputs coming in here. We have our const. We have our correct amount. We have our total run count. Inputs for each. We get our predictions, which gives us this array. Once we have this array, we need to get the index of the highest value of it to find out, is this the correct one? So const, so predicted like index, and this is going to be just find largest index, and we're going to pass it in the predictions. So that will give us 0, 1, 2 for this one. And then we're going to have our if. So we're going to increment correct count if the input has a 1 in that position. So I'll just do a normal if statement for right now. So if prediction, it's going to be expected predictions of position index. If that is, of position index, now we have the current array of position prediction index. If that is exactly equal to 1, then we want to take the correct count and we increment that, which means you need to be a let. Okay, so we're going to loop through those and we're going to find out how many times are we correct. And our accuracy is really just going to be the correct count divided by the total run count. Or is it the opposite way? I always get myself confused this for some silly reason. So if it's 90 divided by 100. This is what living with dyslexia ends up being like, is I question everything even when I'm correct. I don't believe it. All right, so then we're going to come here and we're going to return the correct count divided by the total run count. All right, so how do we test this? Also, calculate accuracy needs to come down here. How are we going to test this? We we're going to be passing the neural network. So we have a little bit of dependency injection going on here. Our current input, why are we not? You need to be current input. So the neural network, we're kind of ignoring these inputs. It's really just being used. So if we just say neural network responds with whatever we feel like responding with, then we're really testing independent. So if I say, let's see, back down to here, calculate accuracy. If we have 3 inputs, these are stubs. We don't really care what they are. We just know that we want to calculate like 1, 2, 3, 4, 5. We want to calculate 5 times, or maybe 10 times, so the math is a little bit nicer. 6, 7, 8, 9, 10. Our expected predictions are going to be a little bit more interesting because we're going to be able to control our neural network. So this is going, we don't really care what this takes in. We're going to respond with an array of values. And then we have our expected outputs, expected predictions. That's an array of values also. So this is going to be something like 0, 0, 1. So let's try this. 1, 0, 0. If it always responds with 1, 0, 0, regardless of what's put in, our inputs may be this. We need weights. In fact, inputs, oh, we just need this to be long enough to loop over 10 times. That's all we care about. The weights we don't really care about. It could just be an empty array. Okay, we got that coming down there. I want to bring this in here too. So how is this going to be used? Calculate accuracy. We need our inputs, we need our weights, we need our expected predictions. So this is going to be mirrored to this. So we can have like 1, 0, 0. If we want to do this 10 times, then we need 10 of these, right? So 1, 0, 0. So this is, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will be 0 and 1. 0, 1. So this is 8 out of 10 correct. That should be 80%. So const expected output is going to be 0.8. So I think we can assert dot equal calculate accuracy. We're going to put in our inputs. All right. Am I correct here? Am I going to get 0.8 out? Let's find out. Hey, it got it right. So if I say 0.7 to make it wrong incorrectly, expected 0.8 to equal 0.7. Why does this not look like the rest of my Mocha test? Why does that just look like a console log? That's so weird. I should begin like the red and not equal to each other. Oh, I lost the it. I don't have the it. That's why. Should display the percentage correct predictions. There we go. That's what I wanted to see. And so when we move you back to 0.8, we're getting the number of passing here. All right, so back to your training. We have training pass 1 complete, and now we want to determine how correct are we. So we need to pass in, well, I guess we just need to get const accuracy equals calculate accuracy. What do we need? We need the inputs. That's going to be our, our test images. So what is that? Test images. .0 test images is not the input. We need to create an array of these actual test images. I don't know if I have them right now. Oh, interesting. Okay, so it's in a format that our neural network might not like right now. I need just an array of all of the images, and right now I don't have that. So I do need to change that around a little bit. I think that's going to be a simple map. So let's actually just fix this right up here. So our test images equals imageset.test. It should look like the exact same thing here. It's going to be an array of objects that has input and output. Test images inputs. we're going to set this equal to test images. We're going to map through. We're going to get a current image, sort of like object. And oh, that's going to be fun. We're going to get test image input. Oh, I guess, okay, so I'm just going to get the image object dot input. Because I think that's, yeah. I want to do the exact same thing. Cost test images outputs. The image object, dot output. Yes. So that should give us our the test images inputs and test images output. We're going to use that down here. The weights. So weights is currently set up here and updated. So I just have access to the weights. Expected prediction. So test images outputs and the neural network, which is this neural network we have. And we want to console.log accuracy. All right, you think this is gonna work? We did a bunch of coding and we did some mapping over and changed some things around. These predictions are not needed for us at all. I don't know, yeah. After one pass through, we're going to find out how accurate it is, or it's going to crash because I did something wrong. All right. We should have like a bet on, I should like create some kind of like system where everybody can bet whether or not this is going to compile correctly and run the way we want to. But all right, let's do it. We know it takes around 8 seconds or so to run the training data. Are you sure I want to do that? It'd be fun. Training pass 1 complete. Accuracy 11.39%. All right. That's, I mean, it's not a great number, but I just only trained once. So what do we, if I want to then train again, how do I do that? I need to put, this all just runs from top to bottom, doesn't it? So creating weights, here's the alpha. Okay, then I have this for loop in here where it's looping through each of the training images. Okay. If I throw this into a function, I can call it down here. And I could have a function for like, then I can just say, okay, train, like run this again after I'm done. So let's call this train. All right, so that should work here. I could then call train on it any number of times I want. It will do another full pass through the system. You know what would be really nice here? After we run through it, I can set this up. Let errors, and this is going to be my errors. I can return this at the end. And I can set the number of epochs, number of times the network trains before testing it. Yes, absolutely. Although it might be fun to watch that, that accuracy go up over time. I'm still not doing anything with this errors, but I now have this. I guess I could deal with, I don't know what I want to do with it right now. Because right now the accuracy is all I'm really caring about. But let's say we run this and we get our accuracy. I want to now loop through, let's say 10 times. So for let count equals 0, count is less than 5 times, count plus 1. Okay, so training pass, we're gonna make you a so training pass count, pass complete. We get our accuracy, and then we're going to console log our accuracy for that. And then maybe just a just an empty one. I know I could just do like another \n, but I'm just gonna lazy man's new line. Maybe what I'll do is 1, 2, 3, 4, 5. We'll just do a bunch of asterisks. So now we should do 5 trainings, and we should hopefully see it go up each time. Or stay exactly the same, which is not exactly what I wanted. Did that feel like it was a little bit too fast? Did I train again at all? Did I completely forget to train? We never trained, did we? Train has never been called. That's kind of hilarious. So we want to call train. Yeah. All right, this is taking an appropriate amount of time. It's still the same accuracy. This is still the same accuracy all the way through. So I'm doing something wrong. Are the weights being updated? I think they should be. Because our weights are being set equal to the new weights, which is a global here. And so I have access, and I'm using those same global weights. But I mean, that's a good question. I could, in between each time here, let's do 2 times. At the very beginning, let's see, console.log our weights. Oh wait, this is gonna be a nightmare. It's mostly gonna be a nightmare because, all right, I'm gonna cheat. Instead of console logging weights, I'm gonna grab the current weights as a string, and I'm gonna check to see if they're exactly equal to each other. So, const current weights equals json.stringify weights. And I just want to, after training, I want to compare. So this is going to be a console.log current weights is exactly equal to json.stringify weights. If they're still exactly the same, then we didn't update the weights. Weights updated. Why am I stringifying the weights? Because they're objects, they're arrays of arrays. It's and arrays are done by values, so weights updated true. So it is different. This accuracy is different than last time, wasn't it? Am I getting random image values? I mean, the accuracy is still random, like it's still the same across both passes. If it's true, both of them are the same. You're right, yes. I should weights not updated if they're exactly the same. Weights not updated. That's what I needed to say. All right, you're right. Thank you, Katali. So our weights did not update here. That's really sad. Like this, so this line, predictions, I'm just setting the weights to be here. Yeah, I know I could have done a not equals, but I just changed the label. We then set that equal to the new weights. Then we go through and we run the train. I'm running out of time. I'm gonna need to go soon, but this is this is not fun for like figuring out why are they different. I'm not sure off the top of my head right now. I may have to think about this and debug it a little bit. I could have it return the weights instead of the errors. Let's try that. The new weights. So we're going to call train. We're going to get new weights. Are the weights not updated? So the current weights, we stringified them. And now I want to stringify these weights too, so the new weights. So the reason why I have to do stringify is because arrays and objects are passed by reference in JavaScript, and so I'm only then checking the reference, like if those are the same. And I really want the content, like to check the content. Because if I need new weights like that, then all right, let's run this and see if we get the same weights not updated. New weights is not defined. Except right there. All right, what line was that? Line 69. Oh. Yeah, it's outside of here. That's the problem. Const new weights. We're updating the weights here though. What if I just respond with weights? Yeah, JavaScript scope. Fun problems, right? They're still not being updated. Or at least the weights that I'm seeing are not being updated. All right, I'm gonna have to think about this to figure out how I want to do the weights. And I may tinker with it outside of here, outside of the stream, to sort of like figure this out. If you all have any ideas, let me know, and I'll and I can update it. I'm gonna push all this code up, so close all these, make sure they're all saved. Training over all the images. I'm not sure if this is a consequence of the following, but there are some good reasons why you want the starting weight matrix to be 1, non-zero, and have small and variable weights. Oh, so you think like maybe because there are zeros, like it's screwing up the math? You could be right. Like maybe when I create, instead of create a zeros matrix, create like a random matrix, and it just has all the weights random between 0 and 1. I'll have to play with that. But until then, yeah, Kotali, I think that's probably a good next step. I'm gonna have to look into that next time. Not next time, but like in between this time and next time. Where's my learning? I don't have it here. Training over all images. So the code has been updated. It's all up on GitHub. Let me share the link out. I have the next stream that I'm planning is going to be next week. No, next week? This upcoming Friday. So in 2 days, in the morning at 6:45 a.m. I'm going to keep on playing with this. So if you want, like, if I figure it out and I get it working, I'm going to tweet out about that. So you can follow me on Twitter if you want that notification. Otherwise, you can follow me here on Twitch if you want to be notified, or just see me in your dashboard when I'm live. Of course, I'm also archiving all of these videos over to YouTube. So if you're interested in getting those, the link to YouTube, my YouTube, is down below in the stream description, I guess. I'm also tweeting out when those goes out. So yes, thank you all for stopping by. I hope you all have a great rest of your day. And also, yeah, I'm glad to do this. It's a great way for me to learn and sort of keep myself going. So with that, I'll see you next time, whenever that is. Probably Friday.